Okay, welcome back to part 2 of our Getting Started Fluid Flow tutorial. In part 2, we're going to perform a high fidelity simulation of the problem that you tackled in part 1. So to switch to high fidelity mode, where you will be using our Ansys Fluent solver under the hood, simply click here to switch to analyze mode. Okay, now let's take a look at this in 3D. Now you'll notice that all the inputs from the previous simulation in explore mode have come through. We have our flow inlet number 1, flow inlet number 2, flow outlets, and so on. So these are all preserved. But we have access to more controls now. So you'll notice on the ribbon, we have access to fidelity controls, we have access to more simulation options, and so on. So in this tutorial, we're going to go through some of those additional options that you have available to you when you switch into analyze mode. So first of all, let's get out of cross-section mode by hitting D on your key. So we're going to apply some local fidelity or local mesh controls. So to do that, click here and then triple click on one of the fluid domain faces to select the body. Make sure you look down here to ensure that you've selected the whole body and not just a few faces. Okay. Then let's apply a local fidelity control of 5 millimeters. So to do that, just hit the number 5. You'll notice the default unit is meters, but you can easily apply millimeters by simply typing the letters mm and hitting enter. Okay, and then hit exit 2 times to exit this to dismiss the heads-up display. Now you'll notice on the tree this fidelity adjustment setting shows up. Okay. Now, one of the things we want to do in analyze mode is to predict the precise pressure drop in the system. And we're going to do that by monitoring the pressure at the inlet. So click on this face and control select this face. Click here to expose the halo, and you'll see this is the icon for monitors. Okay. The variable we're going to use is pressure, and we're going to monitor average pressure. So click the check mark, and then hit escape 2 times to dismiss the HUD. Now you'll see a little box pop up, and we want to click on the details to be able to review and track the convergence behavior of the average pressure value at the inlet. Okay, so we're more interested in the details, so we can close this first box that was revealed to us. Okay, now we want to do one more thing before we move on. We want to specify some different convergence criteria. So click under simulation options and additional fluid flow options. You'll notice that we have many different controls available to you. So the first thing we want to do is change the convergence option from numerical convergence to monitored value convergence. What this does is once the value for pressure at the inlet stabilizes, it will automatically stop the simulation. The other thing I just want to point out is that we have the option to specify different turbulence models, change convergence settings, and so on, and so forth in here. Okay, so this is just where you have more access to more Fluent solver controls. Okay, so that's pretty much it in terms of setup. Since we carried over a lot of the settings from the previous simulation we did in Explore mode. So to run this simulation, just hit the green solve button. Now, keep in mind that this is running on the CPU and it is running a much higher fidelity simulation. So you are going to get, it's going to take a little bit longer for the solution to complete, but what you're losing in terms of speed, you're gaining in terms of accuracy and fidelity and additional physics. Now you'll notice the SID at the bottom, or the simulation information display, has a green kind of line going around it. That indicates the progress. When that green line goes halfway around, you'll be able to view the mesh and so on. And when that green line goes all the way around, of course, you'll be able to view the results. So let's pause this for a second and then come back when that green line is about halfway around the SID. Okay, in about a minute or so, you see the progress bar, the green progress bar has kind of gone halfway around. When this happens, you can actually view the mesh while the solve is continuing to go on. So to view the mesh, click on this icon. Okay, and in a second, you'll see the mesh being displayed for you to inspect. Okay. Okay, there you can see the mesh is displayed. Now let's go back into cross-section mode by clicking on the z-axis again in the global coordinate system and hitting X. So here's the mesh. And you can see that because we're using our high fidelity Fluent solver under the hood, we have a very detailed mesh with automatic refinement near areas of high curvature, as well as automatic refinement in areas of proximity. You can view this in cross-section mode by clicking here. And you can see that we also have automatic refinement near the walls and so on. So these are all settings that comes from our decades of experience in fluid flow simulation, where in analyze mode, you can get a much higher fidelity result to predict precisely things like pressure drop and so on. So the solution is initializing right now since the mesh has been created. And in about a minute or so, you'll start to see the solution progression on this chart that we have created for average pressure. So let's just come back in another 30 seconds or so. Okay, in about 30 seconds to a minute, you'll see the chart starting to update. Now, keep in mind that this chart is monitoring the average pressure at the inlet. So as the solution goes through the iterations, you'll start to see this chart being updated, okay? And because we turned on the option for convergence based on this monitored value, what's going to happen is you'll see this chart develop as the iterations go on. And once the value for average pressure kind of starts to flatline, the solver will stop automatically. Okay. So for this particular example, it should take about 60 iterations. You can see the iteration number on the y-axis, or I'm sorry, the x-axis of the chart. So, in maybe about 5 minutes or so, 5 to 10 minutes, depending on the speed and power of your computer, this solution should be done. So I'm going to pause the video and I'm going to come back when the solution is done. You can see here after just 9 iterations, the solution is starting to trend in a proper way. By the way, if you're satisfied with this mesh, you can just turn the mesh display off by clicking on this icon to hide the mesh again. So now basically when the solution is done, we'll see results displayed. You can overlay the mesh on the results, but we'll show that to you in a different tutorial. So once again, I'll come back to you when the solution is closer to being completed. Okay, you can see after about 25 iterations, the value for pressures already started to flatten off. You're probably going to see a few more oscillations, but this is not really something you need to worry about with it because the solution will automatically monitor the value for average pressure and stop when it feels it has reached a converged state. So like I said before, this should take about 60 iterations. So let's give it a few more minutes to solve. Okay, you can see that the solution is actually converged. The green progress bar on the SID has gone all the way around. So actually it took only 42 iterations, not 60 as I originally said. So that's good. Now you're going to see the little progress bar go around a little bit longer. While it's doing this, it's processing the results in the background. And in just a few moments, you'll be able to visualize the results in the analyze mode. So just give it a minute or so, and you'll be able to see those results. Okay, so the results calculation is done, and you'll see here the results displayed using the same results option as you did previously in Explore mode. So you can see here a high fidelity solution at a much higher accuracy, providing you the precise pressure drop value, which is displayed on the top right corner. Okay, so the average pressure drop. You can dismiss this chart by clicking on X over here. And then, of course, you have access to all the same results types. So you can turn off the LIC contour plot, and let's click here to go to the contours. We can change this from highest value to outer, okay? And then if I turn on the cut plane and then turn on the mesh, you'll be able to see the mesh overlaid on these results. So once again, you can play around with all these different options, but this is basically how you can obtain high fidelity results in analyze mode, where we use the Ansys flagship Fluent solver under the hood. Okay, so with this, we conclude part 2 of this getting started tutorial. We recommend that you look at the other tutorials in this series, as well as the in-depth tutorials for even more information. Thank you very much, and we hope you enjoy using Ansys Discovery.